Welcome back, everyone, to today's explainer. Okay, so if you've ever had to wrestle with extracting data from complex PDFs, you already know the trauma of misaligned bounding boxes and entirely broken text pipelines. It is a nightmare. But today, we're actually transforming that process entirely. We are going to break down a complete end-to-end workflow for running a seriously incredible vision language model on high-resolution images and even multi-page PDFs. We're going to build this step-by-step, straight from the source material, so let's just get right into it.
So ask yourself, what if OCR just didn't need a separate layout analysis stage? For the developers tuning in, you know exactly what a massive headache this usually entails. The traditional optical character recognition pipeline is honestly like a fragile house of cards. You've got to isolate bounding boxes, run a model to figure out what's a header or a table, write super brittle regex, and then somehow piece all that fragmented text back together. It's tedious, it's highly error-prone, and you need multiple models just to read one single page. What if we could literally skip all of that?
Well, enter our hero of the day, Baidu's Unlimited-OCR. Now, this isn't just a minor update to old tech, it's a completely different beast altogether. What we're looking at here is a 3 billion parameter vision language model, and its absolute superpower is one-shot long-horizon parsing. That means it can look at a dense, messy document layout and just understand the whole thing in a single decoding pass. It completely bypasses those clunky old layout stages.
All right, here is our roadmap for the explainer today. We're going to start with the End of Classic OCR, then move right into setting up your environment. From there, we'll generate some complex sample documents, compare Gundam versus base mode, conquer multi-page PDFs, and wrap the whole shebang up with a practical developer cheat sheet.
Okay, let's dive into this. Section 1, the End of Classic OCR, moving beyond multi-stage pipelines. The contrast we're looking at is honestly pretty stark. On one hand, Classic OCR demands this fragile, multi-step pipeline with a totally separate layout analysis stage bolted onto it. But on the flip side, Unlimited OCR just reads the entire page, the headings, the paragraphs, the tables, and emits perfectly structured text in one single shot. It's a massive paradigm shift, going right from clunky, fragmented extraction to holistic document comprehension.
Moving right along to Section 2, setting up your environment, the foundation for inference.
Now, we aren't going to get bogged down reading lines of code here, but understanding the intent is super important. Step 1, we just install the essentials, things like transformers and PyMuPDF. But Step 2 is where it actually gets really smart. The script automatically detects if your GPU supports bfloat 16. If it does, it optimizes for it on the fly. Otherwise, it just falls back to float 16. So we're optimizing the hardware before we even touch the model itself. And then in Step 3, we finally load up that massive 6 GB, 3 billion parameter powerhouse.
Next up, Section 3, generating complex sample documents, creating the ultimate test.
To really push this model to its absolute limits, the source tutorial uses Python's PyL library to dynamically draw these highly realistic document pages. Now, these aren't just plain text. We're talking titles, footnotes, and really dense structured elements. Just think about that regional revenue data. By feeding the model these custom-built images, we can absolutely prove its structural awareness. I mean, the real test is, can it tell the difference between a random scatter of numbers and a meticulously organized financial table? Spoiler alert, it totally can.
Which brings us to Section 4, Gundam versus base mode, choosing your single-page strategy.
So when you're running this, you basically have two main strategies. Think of Gundam Mode as a magnifying glass. It uses tiled, high-detail crops. It shrinks the image size to 640, but sets crop mode to true. It scans tile by tile, making it incredibly precise for dense, tiny text. But then you have base mode. Think of this one like taking a single, fast, wide-angle photograph. You turn crop mode off and set the image size wider to 1024. It's way faster and just perfect for clean, clearly printed pages where you really don't need that microscopic level of detail.
But you know, regardless of whether you end up choosing Gundam or base, you absolutely have to lock in these essential generation parameters. You're going to be setting your max length super high, and we'll talk about why in just a second, but you're also strictly controlling AI hallucinations and repetitions with those n-gram settings. Retaining these exact controls across both modes is what ensures you get stable, perfectly structured results without the text just degenerating into some endless repetitive loop.
All right, let's scale this up. Section 5. Conquering multi-page PDFs, stitching context together.
To handle a full multi-page PDF, the pipeline first uses PyMuPDF to rasterize every single page into high-resolution 300 dpi PNG images. Next, instead of just feeding it a single image, you pass that entire sequence into a specific function called infer_multi. Finally, and guys, this is key, you widen that n-gram window we just talked about all the way up to 1024. This ensures that as the model performs a single long horizon inference across multiple pages, it keeps all those cross-page references perfectly coherent.
Just think about that number, 32,768. I really want to visually anchor you to this max length parameter for a second. When you process multiple pages at once, you are literally asking the model to hold an incredible amount of information in its head all at the same time. You absolutely must keep your max length set this high to prevent the output from collapsing in on itself. It just proves how massive the context window needs to be to achieve true long horizon document parsing.
Let's wrap things up with Section 6, the Developer Cheat Sheet, Practical Takeaways.
So, after the processing finishes, the script inspects the output directories, and you'll see the artifacts are incredibly versatile. You aren't just getting some messy, unreadable block of text. You get plain text, clean Markdown, math Markdown for complex formulas, and perfectly structured JSON data. These outputs are literally ready day one for integration into a database, a retrieval augmented generation pipeline, or, whatever downstream application you happen to be building.
Let's do a rapid-fire summary here, just to empower you to apply this to your own files right away. Dealing with dense, small text? Use the tiled Gundam mode. Got clean standard print? Go with the faster base mode. Handling multi-page PDFs? You'll want to use that infer_multi function with an image size of 1024. And for anything long, absolutely for sure, keep that max length at 32,768.
I want to leave you with this final thought. We have just seen a 3 billion parameter model handle complex layouts, precise tables, and multi-page stitching entirely on its own, without relying on a separate layout analysis stack at all. So I have to ask you, with one-shot parsing seamlessly handling these dense layouts, are your traditional document pipelines officially obsolete? It might just be time to reconsider your current data extraction stack. Thank you so much for joining me on this explainer, and keep building.